Hi guys, today I want to discuss different types of scoop marks discovered on various ancient megalithic sites around the world. The mysterious origins of these stone markings have spawned a wide range of speculation. The most famous scoop marks are the ones at the unfinished obelisk and other areas of the granite quarry at Aswan, Egypt. These curved excavating marks appear as if the granite was softened like butter and scooped out with a shovel. Did the ancients have certain high-tech tools to cut stone that left these distinct scoop marks? Decades of debates have not resolved the scoop mark origin, but instead broadened the topic to more scoop marks in other regions. Similar markings are said to be found at multiple locations in Peru, such as Cusco, Ollantaytambo, Sacsayhuaman, and Machu Picchu. Some claim that such markings also show up at Stonehenge in England, Yangshan Quarry in China, and some other sites scattered the planet. From online photos, scoop marks of different locations do seem to share interesting resemblance, which in turn pose a series of questions. Why are there similar scoop marks at ancient places all over the world? What's the nature of these scoop marks? Are they the same or are they different? How were they created? What can we learn from these scoop marks? In this video, I'll show you 4 different types of scoop marks with detailed photos and side-by-side comparisons. I'll also present my thoughts on the possible methods that created them. The first type of scoop marks are the ones at the ancient Aswan granite quarry and another quartzite quarry in Egypt, which is the origin of the scoop mark name. On and around the unfinished obelisk, there are indented square scoop marks. These indents have similar dimensions of 40 by 40 centimeters. The vertical scoop marks are also 40 centimeters wide. This implies that the cutting face of the tools utilized to excavate the unfinished obelisk had a defined size. The rock underneath the obelisk had been cut out from both sides and only a narrow central portion left, attaching the block to the bedrock. In my prior videos, I explained although the stone appears to be softened and scooped, softening granite to a ductile state using either frequencies or heat for quarry purposes was not practical. Despite the prevalence of scoop marks at Aswan Quarry, there is no scooped granite nearby. This means the Aswan scoop marks most likely had been broken down by a tool that left scoop-shaped trails. I compared the vertical scoop marks of the unfinished obelisk with diverse vertical marks found in modern quarries, as they are all excavation markings generated during the process separating stone blocks from surrounding bedrock. The quarried facades are not as smooth or consistent as the modern circular drilled surfaces, and the scooped rock faces can be uneven, patchy, and bumpy. They do not have sharp striations like chisel, modern rotary drum cutter, or drill marks. They are also different in scale, shape, and size from the markings produced by water jets. The Aswan scoop marks cannot be the result of chemical reactions either, like what the neutron theory proposed, since there are neither stone discoloration nor chemical reaction residue on site. Plus, the chemical method cannot explain why using the chemical reaction to dissolve and weaken stone needed to be in specific sized scoop mark shapes. The physical characteristics of Aswan scoop marks have me pondering that the drilling which left scoop trails was neither mechanical nor precise. As advanced as it was, the tool was used as the first step to rough shaping and separating the stone blocks from surrounding rock, but not for more precise cutting and detailing. If the scoop mark creation did not rely on mechanical forces or chemical reactions, then there is one logical choice left: heat. I proposed that the scoop marks might have been created through a thermal jet torch, which directs a high-temperature flame against the granite, causing the surface to flake off due to rapid temperature changes and thermal stresses. This is a plasma spallation machine invented by EarthGrid, a Bay Area tunnel boring technology and infrastructure development company. EarthGrid designed the world's first plasma tunnel boring machines, which employs high-power plasma torches that can reach 48,600 degrees Fahrenheit or 27,000 degrees Celsius to vaporize and break down rock into small fragments, and are able to bore deeply, approximately 10 to 100 feet, 3 to 30 meters below the surface. The plasma plumes bore quickly with spallation and vaporization, allowing excavations with greater precision, speed, and depth. Here are photos of a tryout with a two-torch system on a granite block. The torches left a sizable depression with defined outlines on top and soft and curved lower edges, and two scoop-like indents. The size, depth, shape, and cut edges are not too different from the Aswan scoop marks. In June of 2025, at the Sierra Granite Quarry, EarthGrid utilized a two-torch system to drill a channel on the bedrock. The plasma torches successfully cut through granite and made a channel with efficiency. The finished channel work is comparable to the trench around the unfinished obelisk in widths and morphology, and both were dug in natural granite. The channel opening is not perfectly straight, but somewhat deviated, like the trench surrounding the unfinished obelisk. They both are accurate enough, yet not as precise as line drilling or saw cutting. The top of the Sierra Granite Channel is rounded with curvatures, like this part of the obelisk trench. The Sierra Channel wall has slanted vertical patterns. Each vertical stripe ends at the bottom of the channel with a curved corner. These characteristics resemble the vertical scoop marks of the obelisk trench and a ridged trench bottom with curved corners. Do you agree that the excavating marks from the plasma torch system are similar to the scoop marks at the Aswan quarry? Let me know in the comment section. The EarthGrid plasma rock boring system was invented in recent years. This type of high-tech equipment was obviously not available in ancient Egypt. If the Aswan scoop marks were really created by plasma torches, as evidence suggests, then these marks cannot be the work of ancient Egyptians, and the unfinished obelisk had to be quarried by an earlier civilization, a developed one that possessed plasma technology and powerful cranes to lift and transport the obelisk. The Aswan scoop marks are advanced excavation marks to cut and shape hard rock. Are scoop marks at other ancient sites the same? Let's go to Peru and check out their alleged scoop marks. The Peruvian scoop marks are on the surface of many megalithic polygonal walls. Unlike Egyptian Aswan quarry markings, they are not excavation marks and seem to serve no meaningful function. They are not on quartz-rich igneous granite or quartzite, but on softer stones such as limestone. These marks are shallow and superficial, only pop up randomly on some blocks. Their existence have no impact on the wall's construction integrity. There is no good reason for stonemasons to carve out these surface scoop marks, and they look like scraping marks left on uncured concrete. As we see, the scoop marks at the Peruvian sites are different from markings at Aswan. They are the second type. I call them scraping or scraping marks, and their formations relate to specific building materials. Besides these markings, there are also stamp-like indents on many bulging blocks. At Coricancha, there looks to be a long, shallow scraping mark going across multiple blocks. Here is a similar scraping sign on a polygonal wall in Cusco. These scoop or scraping marks are clues that these ancient blocks were once soft and malleable during construction. In a 2020 video, I proposed my theory that the massive megalithic retaining walls of Sacsayhuaman used cast stone, and explained how the walls might have been built. I cited a 2012 material analysis report done by a group of geophysicists, which concluded that the block material is not natural. It's possible that a sophisticated civilization mastered the techniques of creating special geopolymer or concrete, which had a plastic state before it cured or hardened, in a similar way to today's dry cast concrete. I believe these super-precise Peruvian megalithic polygonal structures were created with concrete or geopolymer, not stone. Pouring and casting concrete on site would be much easier and more efficient. Casting can make custom shapes, which works best as opposed to the labor-intensive job of quarrying, transporting, and cutting stone to unique shapes with perfectly fitted curved joints. After preparing the site, the base layer would have been laid out and the workers would work their way up block by block and layer by layer until the project was complete. Larger blocks can be directly cast in situ. Smaller blocks can be cast in molds, then placed on the wall when they were in a still firm yet pliable state, which means they kept their basic forms and had some flexibility. Once the semi-cured blocks are laid out in horizontal rows and vertical layers, they will be compressed from above and pushed on the sides to get rid of any gaps and thereby ensure a tight fitting. An analogy might be squeezing Play-Doh balls together. This practice would have produced very tight and somewhat organic seams observed at these sites. Even if the blocks came from the same mold, the compression or manipulation of the blocks would make them adjust to various unique shapes. Here is a photo of a stone wall at Ollantaytambo showing the normally not exposed top and inside portion. The non-exposed sides of the blocks are as smooth as the facing sides. This is further evidence that the blocks are cast, because neither old-time workers nor today's modern masons would spend a tremendous time and effort to dress stone surfaces to this level of smoothness when they would be covered up by other blocks. There is no point of doing so, while cast stone can easily be smooth on all sides. Four slightly protruded in-between leftover seams are the indicators of previous stone blocks laid on top and where the joints were. These linear seams are not as straight or with a uniform width, but look like flexible ridges. They have the recognizable look of seams created through pressuring ductile cast blocks together. At the lower right of the wall, this imprint presents the shape of the block that used to lie there very precisely, which was smooth with a rounded corner and edge. To chip and carve natural stones to fit in this fashion would be extremely difficult and totally unnecessary, but it would be easy to do with dry cast concrete. These are all telling signs that this Ollantaytambo wall is cast. So, the Peruvian scoop marks are likely scraping marks on cast stone, which means they are intrinsically different from the excavating marks at Aswan. Then what about the scoop marks at other sites such as Yangshan Quarry and Stonehenge? Are they similar or different from the real scoop marks in Egypt? Yangshan Quarry is an ancient stone quarry in China, well known for the 3 gigantic blocks that are still attached to the limestone hill. Some claim that they have seen scoop marks inside the rectangular cutout at the bottom of the largest stone block. Here is footage of the back wall inside the cutout, where the scoop marks are supposed to be. This clear and detailed footage is from a fellow curious being, Bo. Thank you. Visible sharp tool marks can be seen all over the place. Might be chisel or pickaxe marks. And the alleged scoop mark edges and surfaces are pretty crude. In dim lighting, these niche-looking forms might look like scoop marks, but they do not have the smooth, continuous, soft imprint-like features of the Aswan scoop marks. As for the Stonehenge scoop marks on one of the sarsen stones, from online photos, the markings on stone 59A seem to share a resemblance with the scoop marks at the Aswan quarry with curved surfaces. Yet the stone 59A markings do not have the uniformly sized, obvious strokes like the Aswan scoop marks. At Aswan, it's clear that the scoop mark-related tools were used extensively and everywhere for excavation, though the so-called Stonehenge scoop marks only show up on the surface on one side of a single stone, which make me think they're more likely dressing marks that got eroded away. From other angles, the marks on 59A are obscure, coarse, and have lost the scoop mark look. These are the third kind of scoop marks, the scoop mark lookalikes, meaning from certain angles they might share resemblance with the Aswan scoop marks, but are not a real thing. The fourth type of scoop marks do look like the Aswan markings, and they are also on granite. Unfortunately, very limited information is available, thus I named this type the understudied scoop marks. The sole source is from a 1983 report written by Jean-Pierre Prozin at University of California, Berkeley. He documented that during the investigation of the Inca quarrying work, the cutting marks on the few remaining blocks at the south quarry of Cachiqueta, quote, are very similar to those found on the unfinished obelisk at Aswan, and the technique involved must not have been very different from the one used by the Egyptians." End quote. Like the Aswan quarry, researchers did not find many tools at this quarry, only some hammerstones of diorite and quartzite. It would be great if more studies can be done in this quarry region. In summary, there are possibly 4 types of scoop marks. The natures of these scoop marks differ, so are their corresponding creation methods. The first and original is at the Aswan quarry, being stone excavation marks on granite. Although these markings are ancient, they in multiple ways resemble today's cutting-edge plasma torch marks, which imply that they might have been the work of an earlier advanced civilization. The second type is the screeding and scraping marks on cast stone blocks, mostly found at megalithic polygonal sites in South America. The impressive sizes, high accuracy, and durability of the polygonal wall construction indicate that these cast block structures came from a culture possessing sophisticated concrete or geopolymer technology. The third kind is the scoop mark lookalikes, the markings that share remote resemblance with scoop marks but have significant differences. The fourth one is the understudied type that can only be determined as the real scoop marks or not through future research. What do you think? If you have any insights, please leave me a comment. If you like my video, please subscribe to my channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.